In this lesson, we are going to move on to linear algebra number 5, and the goal is try to understand how to solve ax equal to 0. And honestly, this is sort of nothing to do with data science, so it to some degree just it's a required components that is necessary for the future use. The reason is that for many data science algorithm, for example PCA and MDS and some other, for example spectral clustering, all these things require you to learn what is the eigenvalue and eigenvector. Okay, I will write the full name. Eigenvalue is a number, and the eigenvalue is a direction. But in order to find this lambda and v, you often need to solve an equation which is a minus lambda I multiplied by v equal to 0. And just forget about that for now if you haven't heard of this. But if you want to have a thorough understanding of these algorithms, then at some point you need to know how to solve what is the vector in the kernel. Okay, but at this point, let me just give you a very basic example that you are supposed to, supposedly you have seen in high school. So the biggest idea for this lesson is you can use the row operations, and I will show you what I mean. You may use row operations to find the kernel. Okay, so it is not that complicated. Say I have a matrix A, it is a 2 by 4 matrix. And we know that A, let me call that as V, because I want to use the letter X later. So AV equal to 0, it is the same as a set of equation. It is a set of equations saying X plus Y plus Z plus W equal to 0 and 1, 1, 2, 2. Okay, so that shouldn't be hard, and it's basically treating this V as 4 numbers, X, Y, Z, and W. Now, I believe all of you know how to do a little bit manipulation of this. You can use this equation. You can use this equation and subtract this equation from the second equation. Okay, you start with 2 and 2 minus 1, and it will give you a new equation. So equivalently, you got 0 plus Z plus W. And you know these two things are the same. They have the same answer. If you wish, you can use this one to kill this also. Use the number 1 minus number 2. Then you got the new equation further. It turns out that X plus Y equal to 0 and Z plus W equal to 0. And it's not hard to solve that. You can get a lot of different solutions. But that's a key, because all the time in high school, you only get one solution. But now I want you to find all the solutions. So let me copy this part to the second page. Okay, it's very easy to get some solution. For example, 0, 0, 0, 0. Yeah, for sure, it works. And then you can have 1 minus 1, 0, 0. All these works. But the thing is, let's do some observation. The key here is there are two variables that is spatial. X is the first variable in the first equation, and Z is the first variable of the second equation. And now you can determine whatever you give me Y and W, I can always get X and Z. Okay, this is not always true. You see, okay, let me write it down first. What I'm trying to say is any Y and W will determine X and Z. Well, this is not true. If you just give me any, say for example, Z and W, then maybe they will conflict with each other. If you give me Z equal to 5 and W equal to 10, then you already ruined the answer. So the nice thing about here is Y and W does not ruin the answer. You still got the answer, and better than that, as long as you give me whatever the value, I can calculate the rest of that. So in the future, we will call these things as a free variable. But to talk about what is free, you need to talk about what is leading variable. Okay, so basically, leading variable are those variables in the front of every line. Each line will give you a leading variable, and anything that is not a leading variable, it is free. So Y and W are free. So you can suppose Y to be one value and W to be another value. Whatever the value you give me, you can always get an answer. So the answer will look like this. Y is C1, W is C2. And if you have these things, you can calculate X is equal to minus C1, Z is minus C2 because of these two equations. Am I moving too fast for this part? I know mathematics is not so fun, but but you choose this course in math department, right? Okay, but we're almost there. What I want to say is you can do this further. C1, take C1 out. Let me do one more step. You can write it as minus C1 plus 0 C2 plus 0 C2 and 0 C1 plus minus C2 plus C2. Okay, that means that you can use C1 and C2 to control the whole things. C1 you have a minus 1, 1, 0, 0. C2 you have 0, 0, minus 1, 1. So surprisingly, now you got the kernel again. The kernel of A is controlled by these two quantities, and these two quantities can be anything, and this means that it is the span of two vectors. One is this, let's call that as H1, and this is H2. So you got the span of these two vectors is always a solution, and all the solution looks like this. So the big idea here is trying to let you know all the time how you can find a solution, and in the end, once you find the solution look like you can write it as a span of several vectors. And how many vectors here? If you have two free variables, then you have two coefficients. Then in the end, you got two vectors. So if you have two free variables, then you got two vectors in the end. And that's actually the dimension of the kernel. So I want to add something more because you don't really want to write x, y, z, w all the time. What we did can be also understood in the following way. You don't need to do any of this. X, Y, Z, W, forget about that. All you need just the numbers. At the beginnings, you have 4 numbers, and we transform that into linear equations. But what you did is use 2 minus 1, right? So 1, 1, 1, 1, and 0, 0, 1, 1. And you can use 1 minus 2 to kill the rest of that, so you got this. But how do we find the leading variable? We look at each row and then pick the first one. We look at each row, look at the first one, which is non-zero, so these are leading. And the rest of that are free. So in order to solve the equation, let me write it in the middle, a bit bigger. Right? You know you want to assign 4 numbers to make it 0, and you know this guy is, you know this one is free and this one is also free. So let's say this is C1, this is C2, and you look at each row, try to solve the equation. Something plus C1 equal to 0, so this is minus C1, and 0, 0 plus something plus C2 equal to 0, here is minus C2. So again, you got the solution. Just by all these numbers, kernel of A is equal to all the things look like this. Such that C1, C2 are real numbers. And these things, adding some row to the other row, these things are called the row operation. Okay. Really, the last theory that I want to say, just a picture to tell you a big idea. If you keep killing all the rows and using row 1 to kill the second row, third row, you keep doing this, then you are able to generate something looks like this. By this, I mean all the things are 0 on the bottom left. And you got a leading variable here, and so on. So you just keep doing this until you see all the leading variable. And the rest of that are just the free variables. Free means it's non-leading. And the fact is the following. If you want to understand what is the kernel, in the previous case, right, the kernel looks like a line. The line has a 1 dimension. So the dimension of the kernel is exactly equal to the number of free variables. Let me write it on the right-hand side. If I recall correctly, the matrix that I sent to you is something like this. -3 and -2, I guess. And what are the leading? These two are the leading, right? And then only 1 free. So you only have 1 degree of freedom to generate that line, and so you have a dimension 1 for the kernel. And the dimension of the row space or the column space, both of the row space and the column space, their dimension, it is the opposite. It is the number of leading variables. So when you take the sum of these two, then you will get the whole thing is equal to the number of variables. And you can search for something called dimension theory. It tells you that this part is usually called the nullity, and this part is usually called the rank. So it tells you that the rank of any matrix plus the nullity of any matrix is always equal to the number of column or the width of matrix A.